Hello, everyone. My name is Caden O'Shea. We also have Brant Lee, Aiden Lassaline, and Brandon Marshall. Thank you guys for taking the time to come to our presentation today. We are the 4 members of the Injection Molding Capstone. And our goal for this project is to reduce single-use plastics in the environment using a system that can easily be integrated into any sort of developing country for a low cost. On the left there on the title slide, you can see we have our injection molding machine. This is the machine we are currently working with in person at school every Thursday. And our primary objective is to make a functional system which can injection mold single-use type 6 plastic into a usable product. We saw some example molds from last semester where they had a little like earpod case. So something like that. Brant will talk more into that as well. One quick note before we do start, as per the groups before us, we will have a question and answer period at the end. So I'll just start us off with our agenda very quick. During this short presentation, we will be covering the topics you see on screen there, such as our problem statement, what our scope and our constraints are when it comes to the project, various design concepts that we drew up together, and so forth. Many of the topics outlined are our instructions behind this project, as well as some technical details that we feel are relevant to the understanding of the task at hand. Topics will be covered by various members in the group. However, every resource presented was a collaboration effort, with all of us putting our skills, any of our backgrounds into every single thing that we have done so far. And figure 2 on the right there indicates a type of single-use plastic commonly found in landfills, and this is kind of what we're aiming to reduce.
All right, so for our problem, the main problem with plastic nowadays is it's hardly recycled, and roughly not 79% of used plastic is currently in landfills. So we want to design an injection molding machine that uses shredded and clean recycled plastics to form new products. And the end goal of this project is hopefully that it'll be a independent unit control system that can be sold as a separate unit to developing countries, and the rest of the materials needed for the injection molding machine can actually be sourced from locally recycled materials. The scope of this project will include numerous factors and different things we have to do. We'll be developing a PLC and HMI control, as well as a program. PLC stands for Programmable Logic Controller, which will be the brain of our project, or the brain of our machine and our injection molding machine. And the HMI is a human machine interface, which will allow any touchscreen, smartphone, anything like that to have our interface up there. And so it's controllable by that. We have to integrate temperature loops to make sure the plastic is kept at its proper temperature, as well as we will be creating a weighting system, hopper, and feeders for the plastic so we can get them from their storage containers to the actual the heating element itself. We will be creating electrical and pneumatic schematics so that our work is documented, and anyone who wants to reproduce this machine will have easy access to that type of stuff. As well as we're doing our tests on current pre-existing molds that have been completed by years previous capstones. And we've been told if the alternate streams of this year complete their capstones, we will be testing and calibrating molds that they made. As far as our design constraints go, the main issue that I wanted to point at was safety, that when plastic is heated to a point at which it is melted, it actually outgasses carcinogenic and toxic fumes. And so that's the main issue of our design constraints, is remedying that. So we need to keep it at a softening temperature without getting completely molten, because if it does, it could become very deadly to anyone around it or near it if they don't have proper ventilation. So for implementing these systems in a developing country, they also need to be easily manufacturable from scrap materials, and the cost needs to be kept as low as possible. We did some competitor and research information about what we were going up against, or what different options were out there if people were looking for these type of machines. And we found that there was a multitude of samples here that we came to find, and ones as big as floor models for like the Nisei FNX80, as small as the Babyplast 612 will fit on your desktop. But we found that a lot of these models were restricted to prepared plastic beads and were not usable with shredded recycled plastics in any way. They were meant for just these type of beads, as well as their price tag is a lot higher than our anticipated model. And that was the main issue with them we found.
You are now looking at a few of our design concepts, and please feel free to browse them as I'm speaking. The main focus of our designs are on our main hopper system for storing the plastics. As well, each design needs to include a system for how we are going to weigh out the amount of plastic being used. And finally, they require a concept on how to transfer a good weight of plastic to the heating chamber and transfer a bad weight of plastic back to the hoppers for reweighing. The concept for the hopper system is required because it will play a large role in automating our process and will allow the operator to rapidly switch between all 6 types of plastics. The concept for the weighing system plays a vital role in machine cleanliness and operation. If an incorrect amount of plastic enters the heating chamber, we will either have an incomplete mold or we will end up with leftovers still in the nozzle, which would need to be manually cleaned out and put the machine out of operation until cleaning is finished. And lastly, the feeding mechanism. This is important because if we have an incorrect amount of plastic, we want to be able to feed it back to the hoppers rather than throw it away. And if we have a good weight, then we need to feed it to the heating chamber so the mold can be filled.
All right, so this is our performance specifications chart. So we have laid out a number of desires and wants that we wish to include in our injection molding process. But before I get into any of that, it is important to know what we consider to be a desire and what we consider to be a want. So for a desire, we classified it as something that we have to include or that we must include, whereas a want is something that we want to include, but we can focus on later. So if you look at the top one for can injection mold type 6 plastic, that is a desire because as Aiden and Caden said above, it is the plastic that is basically the building block. So if we can figure this one out, we can do the other ones. Whereas can injection mold plastic types 1 to 6 is something that we want to do, but can be focused on for a later time. If anyone has any other questions, feel free to ask during the question time. All right, so here's our morph chart, or our morphological chart rather. And we have a bunch of sub-functions that some are easy to understand and some may be more difficult to figure out. So I'll start with our hoppers and dispensing mechanisms. So what our hoppers / dispensing mechanisms are supposed to do is they're supposed to hold on to the shredded plastic and then release them in a controlled manner. Now for our exit good or bad, we have already decided that we're going to choose our weighing system to determine the correct amount of plastic needed. So if the weighing system is if the weight of the plastic is drastically higher or drastically lower than the correct amount, then it'll be pushed into the discard / bad section. Whereas if it's close to the correct amount or is the correct amount, it'll be pushed into our injection molding machine. Now also human interactions. So we've already decided that we're going to go with Bluetooth as it's easy for the operator to use, and our plan is to allow them to use it from their smartphone. All right, and here are the ones that we have chosen or we are deciding if we want to choose or not, but these are the leading ones.
Our injection molding machine operation begins with the operator closing the safety gate located on the front of our machine. This safety gate needs to be closed because it prevents the operator from coming in contact with the heating element, and pneumatics will not function unless the door is closed to ensure the operator does not have a hand in the piston while it is pressurized. The operator then uses the HMI to lift the piston and select which of the 6 types of plastic they would like to use for their mold. Once done, the design concepts we discussed earlier will dispense, weigh, and feed the plastic into the heating chamber. And from here, the plastic is heated and the piston pushes it through the nozzle into the mold.
To summarize, we aim to reduce one-use plastics in the environment with a system that can be implemented in developing countries for a fairly low cost. Through extensive research, planning, and a ton of hands-on work together, we are hoping to reduce the impacts of single-use plastics and also put them to a good use at the same time. Thank you everyone for your attention. If you have any questions, please feel free to ask them now and we will do our best to answer them.
I don't know if you guys can. Okay, go ahead, Lee.
Go for it, Rich.
Just curious, guys. I do understand that one of the benefits of your machine is that you shred the plastics, but I'm curious with regards to if you talked about consistency of the product itself, as well as the difference or the reason behind shredding versus something that's consistent with resin that they know has got the same quality product?
So the purpose behind shredding the plastic is what I believe you're asking, rather than using like pre-beads, is we want to be able, and currently we're doing this with Tim Hortons lids. We just have to like shred them up to about the size of like your fingertip, and then they can easily go in there and be melted and pushed through the nozzle. Like and beads are just too hard to come like pre-prepared, and we want to be able to implement this in like landfills. I hope
So
that
so is that does that mean that there's another stage before this where they have to separate the different plastics in order to have consistency of product?
you would need to separate them by their plastic type, but it doesn't matter what it is, as long as they're all type 6 plastic in the same hopper and they're like pre-shredded to about the size of your fingertip again, they will work together.
Yeah, it's more so because the different types of plastics have different softening points. So if one is much lower, then it could turn into, as Brant said in his, it could turn into basically molten and then off gas, which is really dangerous.
Can I ask a question?
Okay.
Yeah, what's up, Julian?
This project really interests me, and I was really excited for you guys to be doing this. Have you, at this point in the project, estimated an overall cost for the unit?
We haven't found an overall cost yet. We've still been in the process of sourcing materials, and we just got one of the pneumatic valves we needed to make the piston operable this week actually. So we haven't got to a full estimate of cost. We've been told that the desired estimate for just the control system by itself is around $200. And from there, the rest of the pieces can be sourced. So we're trying to go with like 3D printed things so they can be sourced from different materials. They can be crafted however they want. So at this moment, we don't have a set figure. We have figures we'd like to end up at for the control system for sure. And for the main object, which are just trying to keep it as low as possible using whatever we can find or whatever can be thrown together to hopefully satisfy this project. So yeah.
Yeah, no, that's awesome. I was just wondering because I work for a plastics company, and they're looking for recycling projects similar to this and reusing their offcuts. So this is very interesting, and I'd like to be in this loop. It's a super cool project.
Yeah,
absolutely. Thank you for your question, Julian.
I had one question regarding the project. You guys said initially in your presentation that you were wanting to try and implement this in landfills and third world countries. With those kinds of settings, especially the third world countries, why are you going Bluetooth?
So or you can go for it.
Okay. We feel that Bluetooth is accessible to most people if it's a touchscreen unit that's attached to the physical device. Then it needs to be maintained. It needs to be this. We found that using a Bluetooth HMI would allow anybody to have any type of touchscreen smartphone, any year, doesn't matter, as long as it's functional, to be able to control this machine, allow them to do whatever they need to do without having external PLC control from a different interface or anything like that. We just feel like this is the easiest and most accessible option.
Awesome,
as Brant was saying as well. Oh, sorry.
No,
Can I add one
okay,
thing
go
to
ahead.
Brant there? With having a physical screen, instead of having it shipped out with a manual that's 200 pages thick, we can have it basically a walkthrough on the screen at the same time as the operator is using the machine. So therefore, instead of having, like I said, way too much reading that no one usually does, having it walk through the steps in every spot seems like a much more accessible way for someone who may be new to this sort of technology.
Okay, understandable. Thank you.
No problem. Thank you. Awesome. Is there any other questions? If not,
Just wanted to add that this is
oh yeah, go for it.
just wanted to add that this is a really good project, guys, and all the best.
Thank you.
Thank you very
Appreciate it.
much. We
Thank you.
appreciate that.
Yeah,
I
thank
believe
you.
our whole team wants to say thank you, everyone, for taking the time to listen to our presentation today. Your interest in our project is greatly valued. And going forward, we hope that we can get this thing working. Thank you all and have a great day.